But the mystery of missing water need not haunt comet scientists if they will question their theoretical assumption that water is necessary to create cometary displays. There's more to this mystery than common theory has even considered. Astronomers assure us that abundant water is detected in the luminous comas of comets. But this is where the real mystery begins. Cometary comas exhibit the hydroxyl radical OH. OH is not water, H2O, but just one hydrogen atom bound to one oxygen atom. Hydroxyl radicals can be produced from water molecules by photodissociation. When a photon of ultraviolet light from the sun strikes a water molecule, it can break the bond holding a hydrogen proton to the oxygen atom. If one of the hydrogen nuclei breaks free from the water molecule, what is left is the hydroxyl radical and a freely moving hydrogen proton, or positively charged ion. What comet scientists believe they see is water released from the comet's nucleus breaking down to produce the hydroxyl radical. They don't see the water itself. But that's how a theory interprets the presence of OH in cometary comas. And it does seem reasonable, except perhaps for the missing water on the nucleus and one additional mystery: the much greater accumulation of hydrogen than of OH in the comas of comets. These great envelopes of fluorescing hydrogen, entirely out of proportion to the presence of OH, suggest that something is happening around the nucleus of comets that the theorists have yet to comprehend. More than 25 years ago, scientists examining the comet Togo-Sato-Kosaka noted the problem. The ratio of OH to hydrogen was clearly too low if the original source was water. Here is a fact that has yet to enter official discourses on comet science. There is a simple and direct way to produce the hydroxyl radical in abundance, and it does not require water at all. Laboratory experiments by Nobel laureate Hannes Alfvén have shown that silicates, when bombarded by protons, produce abundant hydroxyl and other species found in cometary comas with no prior involvement of water. The experimental evidence points directly to charged particles from the sun, not light, and it directs us to the negative charge of the comet nucleus. The evidence for negatively charged comet nuclei has been with us for decades, since the Giotto spacecraft encountered Comet Halley in March 1986, discovering in the coma of Halley the negative ions prohibited by prior comet theory. In the electric model, comets on elongated orbits pick up negative charge while far from the sun. As they move into the sun's positively charged environment, electric discharge is the predictable effect. The electric discharge machining of the nucleus sputters negatively charged oxygen atoms from the surface. These negative ions then combine at some distance from the nucleus with solar wind protons to form the OH radical so prevalent in the coma. Numerous variations in the electrochemistry of the coma are certain to follow, and such reactions would be expected even when no water is present on the comet nucleus. The hydroxyl radical may not mean what astronomers have routinely assumed. The electrical interpretation places a new light on the surprising high-energy emissions of comets. It was only as astronomers began to view comets beyond the spectrum of visible light that they discovered the massive envelopes of more energetic emissions, including not just ultraviolet and extreme ultraviolet light, but X-ray emissions as well. In common human experience, ultraviolet light means an electrical event. It can be a natural emission of glow discharge or arcing in ultraviolet lamps and mercury vapor lamps. In intense electric arcs, UV emissions are always involved. That's why arc welders wear their protective masks, to shield their eyes from the ultraviolet emissions. To explain the surprising levels of UV emission, astronomers envisioned atoms of the coma reflecting or re-radiating UV light from the sun. But if comets are electric discharge phenomena, their remarkable glow in ultraviolet wavelengths could well be a new window to discovery.